Question 31 says if the midpoint of the line PQ is 2, 3, and the point P is at -2, 1, find the coordinate of the point Q. So I drew an illustration to illustrate the point. So here we have -2, 1, which they told us is point P. Then we need to know Q, which I've labeled with question marks because we don't know what it is yet. But we do know that the midpoint is 2, 3. So to get to the final answer of Q, I've drawn a bit of a number line here. So here we have -2 and 2. So those are values on the x-axis, because remember that a coordinate pair is given to you in the x, y form. So from -2 to 2, how many spaces did we pass? So 1, 2, 3, 4. So 4 more will get us to the next point, since that's the midpoint. So 4 more onto 2. 2 plus 4 is 6, so that's your x. Then we do the same process for the 1 and the 3. How far apart are the 1 and the 3? Well, they're only 2 spaces apart. So 2 more onto the midpoint will take you to the last spot that you need to be at. So 3 plus 2 is 5, and that's your y. So in x, y form, x is 6 and y is 5. So 6, 5, option D is your answer.
Alright, so question 32 asks us to find the equation of the perpendicular bisector of the lines joining point P and Q, where P is 2, -3, and Q is -5, 1. So I've gone ahead and drawn us a picture here so we can see exactly what the question is asking for. So when Q is -5, 1, remember that ordered pairs are given in the form of x, y. So for x we go to -5, and then for y we go to +1. And P would be 2, 3, so we go forward in the x direction 2 spaces, and then down in the y direction 3 spaces. So that's our Q, and that's our point P. And so here is the line that connects them. And it wants us to find the equation of the perpendicular bisector. So I've drawn a line that would be the perpendicular bisector of it, or approximately anyway. And so basically what that means is that these two lines form a 90-degree angle here. And in order to find the equation of that line, first we need to find the gradient of the first line. So the gradient of the lines joining point P and Q would be the change in y over the change in x. So the change in y positions here is, let's see here, so here's here's -3 in the y direction, and here's +1 in the y direction. So we can see that it changed a total of 1, 2, 3, 4 spaces. That can also be represented by writing -3 minus, we'll leave it at that. -3 minus 1, and then for the x direction, we keep it this, since we use this as the first number, we're going to use this as the first number in the x ones, right? So now we do 2 minus -5, right? And so we're going to get -4 over, and this becomes 2 plus 5, so it's -4 over 7, right? So we see that we move down 4 spaces and to the right 7 spaces. So this makes sense. Now, this is the gradient of this line. What is the gradient of the line right here? Well, it's important to note that when you have a perpendicular bisector, the equation of the two lines will have slopes that are opposite reciprocals of each other. So, but what I mean by that is that in order to find the gradient of the new line, we have to take the opposite reciprocal of this, or negative reciprocal. So that means that we change the sign, so it was negative and now it's positive, and we flip it to make a reciprocal. So now it's 7 over 4 instead of 4 over 7. So this is our new gradient of our perpendicular bisector line up there. Now, they want us to find the equation of the perpendicular bisector line, right? So knowing, right, so it's the perpendicular bisector. So what that means is that, see, I could have drawn another line out here that would have been perpendicular to this line, but it wouldn't be the bisector because it wouldn't be exactly at the middle. And so to find the bisector of the line joining Q and P, we are essentially taking the average of our different positions. So here's -5, and here is +2 in the x direction, right? And so the midpoint of that is essentially the average of those two values. So we're going to go out. So it's -1.5 here, because if you go from 2, you go out with 1, 2, 3.5 spaces. That leaves you over here with 1, 2, 3.5 spaces, right? So the halfway between here happens to be at -1.5. And then now we have to take, right, where on this line is it? So that would be at halfway between 1 and -3. So, right, because it's at 1 up here and -3 down here. So halfway between that gives us -1. Right, so you go down 2 spaces and you arrive at -1. But from here you go up 2 spaces and you arrive at -1. So that's the midway point for the x and the y. So now we know that this perpendicular bisector line goes through the point that has -1.5, comma, -1, and it has a gradient of 7/4. And then knowing that the equation of a line can be represented by y equals mx plus b, we plug in our gradient, and then we can solve for what b is by using the point that we have. So we plug in -1.5 for x, so that's -3 and -1 for y, and we solve for b. And so you can see I've done our math here, and you get b is equal to -13/8. So that means that this is the equation of the line here that you've been looking for the whole time. But you'll notice that they have it in a different form. They don't have it in y equals mx plus b. They have it solved for 0. But that's okay. We can easily just solve this equation for 0. And so what I did is I multiplied by 8 on both sides. So when you multiply by 8, I'll show you. Multiply by 8 on this side as well. So these cancel. 8 times 7/4 is going to be 14, and because y is 8y. And then you just go ahead and move everything to the other side to solve for 0, and you get 8y minus 14x minus 13 is equal to 0, which is your option C here.
So I've drawn a diagram here from question 33, and we need to use this equation to solve for the value of p. And so what I've done, remember that when I write the small letters, which this should be a lowercase p, that's the lowercase, if I can get this to go away, there you go. That means that I'm referring to the lengths that are opposite from the side, or opposite from the corner, excuse me. So this would be little p, this would be little q, and this would be little r. So essentially, if I want to know the length of p squared, I have to plug in these other values. So p squared is going to be equal to 8 squared, because that's what q is over here, plus 6 squared minus 2qr. And so I've done some simplifying. And then you also have to, sorry, I forgot to add, you have to use this part right here. So this cross. Okay. So then, let me make this clear, open this in parentheses here. So then you go ahead and simplify. So 6 will reduce to 1, while 12 reduces to 2. Then this 2 and this 2 will cancel into 1 and 1. So I'm left with just the number 8. Because this is 1, this is 1, and this is 1. So now I have 64 and plus 36 minus 8. So 64 plus 36 is 100 minus 8 is 92. So p is equal to the square root of 92, which is your option for C. Question 34 asks us to find the value of the sine of theta plus the cosine of theta. and it gives us the tangent of theta is equal to 3/4. So if you have this mnemonic SOHCAHTOA, you can remember that the tangent is equal to opposite over adjacent. That's what the O and A stand for. So here we have theta on a right triangle, and the side length opposite it is 3, because remember they said 3/4. And so then we need to find what the adjacent side length is. That would be this one, and that's going to be 4. And then this is a Pythagorean triple, so that means that 3 squared plus 4 squared is equal to 5 squared, and that's an easy one to remember. But if you didn't remember it, you would just write it out: 3 squared plus 4 squared, which you'll find is 9 plus 16 is equal to 25, and the square root of 25 is 5. So that's how I got the last length there. Next, we need to find what the sine of theta is. Remember, sine is opposite over hypotenuse, so we're going to take the opposite, which is 3, and we're going to put it over the hypotenuse, which is 5. Then we're going to do the same thing for cosine, but cosine is adjacent over hypotenuse, so this time I'm going to pay attention to the 4 over the hypotenuse, which is 5. They have a common denominator, so you can easily add them to 7/5, and then you're going to reduce to 1 2/5, because 5 goes into 7 once, but it leaves you with 2 left over, so 1 2/5, and your option D is going to be your answer. Question 35 basically wants us to find the derivative of the quantity 2x plus 2 cubed. So the first thing that you're going to do is realize that this is a compound function with an inside and an outside. And so first we take care of the outermost function. So the outermost function is x cubed. So the derivative of x cubed, remember, if I were to take dy dx of it, dy dx, so the derivative with respect to x would be 3x squared. So that's where I get this and this, and then I left the inside because that is my x, that's my standing x now. But we're not done because there's an inside function, and so that means we have to use the chain rule. So the next step would be to take the derivative of the inside and multiply it. So remember the chain rule, you're taking the derivative of the outer and evaluating it at the inner, multiplying by the derivative of the inner. So derivative of the inner, what is dy dx of 2x plus 2? Well, this 2 will just turn into a constant. Well, the 2 is a constant, so when you take its derivative, it's 0. And the derivative of 2x is simply 2. So that's where this comes from. Next, you just want to simplify. So 2 times 3 is 6. And I'm leaving this quantity squared. And your answer is going to be B. Question 36 says if y is equal to x times the sine of x, find dy dx. So for this one, we have to use the product rule. And so that says that we're going to take the derivative of the first part and multiply it by the second part left alone. Then we're going to take the derivative of the second part and multiply it by the first part left alone, which sometimes will be written like this. It'll be x prime times y plus y prime times x. So here we go. Taking the derivative of x is just 1 times the sine of x. I left that alone. Then I'm going to be adding it to the derivative of sine of x is cosine of x, and this time I leave the x alone. So my final answer is going to be sine of x plus x times the cosine of x, which is option B. Question 37 says the radius of a circle is increasing at the rate of 0.02 centimeters per second. Find the rate at which the area is increasing when the radius of the circle is 7 centimeters. So first off, we know that the rate of the radius over time is increasing at a rate of 0.02 centimeters per second. Remember that when you see second inverse, you can just read that as per second. We also know what the area of a circle is. It's pi r squared. So the first thing we need to do to be able to answer this question is to take the derivative of the equation for the area. So now we have dA dt is equal to pi times 2 pi r times dr dt. So where did that come from? Okay, so the derivative of r squared is just 2r. However, I'm taking this with respect to time. So I have to respect my time. So I have to put times dr dt because of the chain rule, essentially, is why we do that. If I were taking this with respect to r, I wouldn't need to add this, but because it's respect to t, I do. So now what? Well, now we plug in our dr dt, which we labeled up here as 0.02. The rate of change of the area is going to be equal to these numbers, and you'll notice that I replaced my r with the number 7, and that's because they wanted to find what the rate is increasing at when the radius of the circle is 7. So I've replaced the radius with 7 because that's what they wanted. So now I have, I took these two and I multiplied, and that's how I got this number. And I'm saying times 7 times pi. Remember, I left pi alone because pi is just another number. So that would be 0.28 times pi. And then, so you can see I did my math for that over here. And then I substituted 3.14 for pi, so I could come up with a good approximate answer. And my answer was very close to 0.88 centimeters squared per second, which is your option for B. Question 38 wants us to integrate, and so this is what we're integrating here, this 1 plus x over x cubed. So the first thing I did was I split this up. I said 1 plus x over x cubed is the same as saying 1 over x cubed plus x over x cubed. That allowed me to make two different integrals that I could work with separately. So 1 over x cubed is the same as saying x to the negative third power. To take the integral of that, I would get x to the negative 2 over negative 2. And then over here, I took the same idea. I said x squared is the same, 1 over x squared is the same as saying x to the negative 2. To get the integral of that, I would get x to the negative 1, negative x to the negative 1. And I'm remembering to add plus k at the end to stand in for both of them. So I technically should also have a plus k here, but they will combine into this 1k, and so that's why I only wrote it once there. Anyway, so then I'm left with negative 1 over 2x squared plus negative 1 over x and plus k. So you might be wondering how I got from this to this. Well, remember that when I have a negative exponent, it means to put it on the bottom. So that's where this x squared comes from. This negative 2 was already here. Well, the 2 stays on the denominator, but the negative it doesn't matter where the negative is. Same idea over here. So x to the negative 1 means I have x to the 1 on the bottom, and it's negative. That's why the negative is there. Also, to be able to achieve or arrive at the answers for your integrals, you want to think backwards in a sense. So remember that when you take a derivative, if I'm taking the derivative of, say, x to the negative 2 power, let's say dy dx, I will get x, well, ddx, I guess. I will get x to the negative 3 times negative 2. Because this comes down, that's where this comes from, and then I subtract 1, which is almost where that started, but remember they don't have this negative 2 here, so that's why I have to put negative 2 on the bottom here, so they will cancel each other out. So yeah, you have to practice with your derivatives so you can be able to think backwards like that and figure out what type of thing you would have started with to get here. But yeah, like I said, you arrive here, and so your answer is option B. Question 39 wants us to evaluate the integral of the sine of x dx, going from 0 to pi over 2. So the integral of the sine of x is negative cosine of x. But remember, they want us to go from 0 to pi over 2. And so I drew over here a little unit circle to remind you what that means. So I wrote, well, you want to start with the uppermost, or the one that has the most value, because it's 0 to pi over 2. So we'll start off here. So the negative cosine of pi over 2 minus the negative cosine of 0. And so the cosine of pi over 2 is just 0. And the cosine of 0 is 1. So you can see that over here, the cosine of 0 is 1. And the cosine of pi over 2 is 0. So you're just taking 0 minus 1 essentially. So your answer is negative 1, which is option D. Question 40 says the bar chart above shows the allotment of time in minutes per week for selected subjects in a certain school. What is the total time allocated to the 6 subjects per week? So remember, the final question says what is the total time for the 6 subjects? So all you have to do really is add it all up. So biology has 80, English language has 160, maths is 200, geography is 80, chemistry is 120, and physics is also 80. So I've listed the numbers here, and I've added them. So here you go. This is 0. You get 31 when you add all of these. You bring up the 3. Then you add, and you get 7 here. And that's very close to 720. And I cut off option D on accident, but that would be your answer, would be option D, 720.